I'm Sarah Gilbert, Professor of Vaccinology at the University of Oxford. Last year, at the very beginning of 2020, I started the work on the vaccine that became known as the Oxford AstraZeneca vaccine. In order to start making a vaccine for an unknown disease, we had to rely on decades of experience in making vaccines for diseases that we do know about. This is something I've worked on for 25 years, and we've been working on what we call platform technologies. And what that means is it's a way of making a vaccine that we can adapt to lots of different situations. So once we know how the technology works, we can use it to make vaccines against lots of different diseases. And I've been doing that and concentrating on diseases that cause outbreaks. And then we also started to think about how to use it really quickly if a new disease emerged, one that we hadn't seen before. The WHO called this disease X and wanted people to start thinking about how we would respond to disease X if we needed to. Because we have a very adaptable technology and we've tested it a lot, we know how to manufacture it, we know what dose to use when we give it to people, and we know what reactions they're going to have to the vaccine. It's a good way of being able to get off to a very fast start. All we had to do was find the coding sequence, the genetic information for the coronavirus, and take part of that information and add it into our technology. And that meant that we could get going straight away. The challenges in making the coronavirus vaccine is that we knew we needed to go really very, very fast. So normally when we do vaccine development, we'll do the first stage, we'll make a small amount of the vaccine and we'll do some tests in the lab. And if we like what we see, we'll move on to the next stage. We'll need to raise money at every stage as we go through the development. And it generally goes quite slowly because we do one thing at a time and then have to present our results and trying to raise some more money. But last year, we just had to go as quickly as we could through the whole process. So the challenging part for me was planning the late stage of the process at the same time as we were planning the middle stage of the process and trying to carry out the first stage of the process. So I had to think about all of the different things we needed to do and get them all initiated because some of them take a while to get started. So it was quite an intellectual challenge to plan all of that at the same time. It was all work that we'd done before. I work with a big team of people here in Oxford, and between us, we've done all of these different stages, but we don't normally do them all so quickly and all at the same time. My advice to any young women wanting to go and study biology is to look for a course like I did that's really broad. I think when you're at university, it's difficult to understand the whole field. You don't have enough knowledge to do that. And it's not a very good idea to try and pick a course that's really specialist very early on, because you might find that even though you're interested in one particular area of biology, when you start to study it, you're actually finding that you're more interested in something else. So I think give yourself the opportunity to keep all your options open. I don't think there's any imbalance in women going to study science at university. And even at high degree levels, we have very large numbers of female students. What I do still see is a lack of women at the very top of the profession in the professorial roles. And that's something that I'm trying to work with the University of Oxford to look into why that is, why that still happens now. So of the portraits in the National Portrait Gallery, one of them that does speak to me is one of Professor Dame Kay Davis. She's a scientist who has stayed very much in the same area since she did her PhD. She worked on chromatin structure. She's carried on working on genetics, in human genetics. She worked on Duchenne muscular dystrophy and developed a genetic test for that. And the portrait of her is her in her lab. And what I find interesting about the portrait itself, it's a photograph, is the way that it's so obviously posed, and she's having to do what the photographer wants of her. Which is, I think, again, an example of just being asked to do something that's actually not a true representation. What she's doing is loading a DNA sample into an agarose gel in preparation for electrophoresis, separating out the DNA by size using electric current. And it's something I've done many times myself. And what you have to do is use a pipette that she's holding in her right hand to deliver a very small amount of DNA into an indentation in the top of this delicate, fragile agarose gel. And you actually have to look very closely with great focus at what you're doing as you do it. Whereas in the photograph, she's obviously been asked to look at the camera, please, while you're doing that. And so that's the image that we get. So not a true representation of the work that she's actually doing. The other reason that her name comes to mind is because of what I always think of as the Kay Davis effect. And that's something that happens when a very successful woman in an organization is suddenly asked, because the organization wants to increase its diversity on various different committees and bodies, that same person is asked to join all of these different committees and contribute to them. And that actually has a really bad effect on her ability to continue with her own research. And it's yet another way of, even when women are successful in what they do, there are barriers put up that men don't have to cope with.